Good morning everyone to Makaut Electrical Engineering channel. So again, today we are going to discuss some numericals based on Thevenis theorem and Norton's theorem. So basically on Thevenis theorem or Norton theorem, you are going to definitely get one numerical in your semester exams. Okay, it will be for 5 marks. So basically I am discussing the most important questions which must come in your semester exams. Okay, only see here I am using to apply Thevenis theorem to calculate current through 6 ohm resistor. Basically they will give you a question to find the current, okay, either using Thevenis theorem or using Norton's theorem. Okay, only this value will change. Either it will be 6 ohm, it could be 3 ohm, it could be 1 ohm, it could be 5 ohms, it could be anything. So if you're able to solve this question, you will be able to solve any question in the semester exams. Okay, so see, the question here is given a 200 volt supply is given. Okay, 3 resistors are given, 5 ohm, 5 ohm, 10 ohm. Okay, another voltage supply is given, that is 50 volts, and a load resistance is connected through at the end, that is 6 ohms. So we need to find the current through this 6 ohm. Okay, so applying Thevenis theorem, I made a video on Thevenis theorem. If you have not seen, you can check my channel. Okay, so step 1, remove RL, that is remove 6 ohm resistance. So the moment we remove this 6 ohm resistance from this circuit will be given in the exam, right? So we need to first remove this RL. We will remove this 6 ohm resistance. So remove RL, that is remove 6 ohm resistor. So the moment you remove this 200 volts is there, right? 5 ohm is there already, 5 ohm is there, 50 volt supply is there, 10 ohm is there. Only we are removing this RL. Okay, that is we are removing this 6 ohm resistor. This circuit will become open circuit, right? A and B. Only removing this RL is removed. Step 1 is complete. Okay, 1 mark. Step 2 in Thevenis theorem is to find the Thevenis voltage. To find Thevenis voltage, same circuit will be here. We are applying 200 volt supply is there, 5 ohm, 5 ohm, 10 ohm, and again this 50 volt is there already, right? Only if we are going to find this VTH across this AB. Okay, we know this circuit is open, right? Only current is flowing this across this terminal, right? This circuit is open, means you don't need to see this part. Okay, we know that I is equal to V by R. Don't see this one, this is open, no current is flowing, only current is flowing through this part, right? I is equal to V by R. What is V? Already given, 200 volts, written 200. What is R? R is 2 R are there, right? 5 ohm and 5 ohm. So just add this 2 R's. 5 plus 5, that is 200 by 10, that is current is your 20 ampere. We need to find VTH. To find VTH, first we need to find this current. We found the current. What is I? I is equal to V by R. V is 200, R is 5 plus 5, right? We got the I. Next step, we need to find the voltage across CD. If you see my video, I have marked this two terminal, this and this as A and B, and this as C and D. So we need to find this voltage across C and D. So the voltage across C and D will nothing be equal to, we know that voltage is equal to IR. We found the I. What is I? 200 amperes, right? What is the resistance across R, across CD? 5 ohms. So what will be the voltage across VCD? That is equal to IR. I is 200 into 5. So the voltage across CD will be 200 into 5, that is equal to 100 volts. Also the voltage across AB is equal to the voltage across CD. And what is the voltage across CD? That is equal to VTH, right? See this circuit again. So voltage across AB will be equal to voltage across CD, right? The voltage across AB will be equal to voltage across CD, which is equal to the voltage across, that is VTH, right? VAB is equal to VTH, right? And VAB is also equal to VCD. So can I say that VCD is equal to VTH, right? But don't forget to see this, one more voltage source is given here. So what we need to do, voltage across AB is equal to voltage across CD is also equal to voltage across VTH. So VTH we need to find. So VTH is nothing but 100. We already found the voltage across CD, that is 100, 200 into 5. Current we found, that is 20 amperes. The resistance was 5. So 100, just from 100 minus this voltage which was already given, you will get the VTH, that is 50 volts. Step 2 complete, you will get 2 marks. Now step 3, to find RTH. So first step was open the circuit, second step was to find VTH, third step was to find RTH. To find RTH, just remove the voltage source. The voltage source was here 200 volts, we just removed it. Okay, you see the circuit here, this voltage source is just removed, means like this it becomes short circuited, right? Just draw the line straight, remove the voltage source. 5 ohm resistor was there already, 5 ohm was there. I removed this voltage source also, which was given as 50 volts. So 10 ohm resistor is there, right? We find the RTH. RTH is nothing but 10 plus 5 into 5 by 5 plus 5. How this statement is coming? See, this is in series, right? This and this is in series. Yes or no? Right. Also this and this is in parallel. Okay. So first write this series one here, this side, left hand side. I'm writing this 10 as it is, and just focusing on this two. These two are in parallel. For any two resistors to be parallel, the equation is R1 R2 by R1 plus R2. So same thing I did, R1 R2, R1 5 into R2 5, 5 into 5 by R1 plus R2, that is 5 plus 5. Okay. So I wrote 10 and then we applied the Kirchhoff's voltage law for the resistors which are in series, that is 5 into 5 by 5 plus 5, that is 10 plus 25 by 10, right? 10 plus 2.5, that is 12.5 ohms. We got the RTH value. Next, the step 4 is to find the current. To find the current, we need to draw the Thevenis equivalent circuit. So we found the voltage, Thevenis voltage, right? In Thevenis equivalent circuit, what is there? The Thevenis equivalent voltage is there, that is VTH is there. Thevenis equivalent current is there, that is ITH is there. RTH is there, sorry. Thevenis equivalent resistance is there, and finally your load resistance is there. Load resistance was given in the equation above. You can see there, to calculate the current to 6 ohm resistance, that is the load resistance RL, because it is connected at the end. Okay, so drawing this Thevenis equivalent circuit, how we found the VTH? So we wrote 50 volts here. We found the RTH, we wrote the RTH here, VTH, RTH, and finally RL. We find the current through RL, that is we find this I. I'm doing this just to make you explain how the current is flowing in this circuit. This is a positive terminal, the bigger line is a positive terminal, this smaller line is the negative terminal. Current flows from the positive to the negative, right? So I is equal to V by R. We know that I is equal to V by R, but here two resistances are there, that is RTH is there and RL is there, right? RTH is there, RL is there. So just add this to VTH, V by R, VTH by RTH plus RL. VTH is already given here 50 volts, RTH is given 12.5 ohms, and load resistance is given 6 ohms. You get the value as 2.7 ampere. So definitely this question will come in your semester exam. Only the value might change here. It could be 6 ohms, 3 ohms, 4 ohms, 2 ohms, anything. Okay. So we completed the numerical based on Thevenis theorem.